we started with the case of how exactly to run using error recovery by inserting sync method, right, or a sync keyword inside the tuples. So the tuple was in this way. So if in case non-terminal with terminal, if that was the case, and if I have the tuple as blank, then you need to show it as an error. So if in case terminal with the terminal, and we were actually avoiding it. So non-terminal with the terminal, if I have a sync, then we have to pop up the contents of the stack. So that was the thing which we saw in the last class, and today in this class we'll be discussing about the shift reduce parsing. Apart from LL1 of LL of 1, which was from top-down parsing. So the other method of parsing is something called as a shift reduce parsing, also called as a SR parsing. So in this case of SR parsing, we go with bottom up, right? So bottom up parsing, so bottom up method. So this is top down method. So in bottom up parsing, we looked into where we start from the input. So we start from the input, gradually we go towards the root. So with the top down, we started with the root, in other words the starting symbol. From the root we started, and we ended up getting my inputs, right? So we started with starting in the sense start symbol with dollar, and we encountered with respect to something called as W, that is a string. So here we start with W, and we end up our production to the starting symbol. So these are the main thing which we'll be looking into the consideration. So shift reduce parsing is one particular method of getting to know whether via the parsing can I get the thing which I am looking for, right? So shift reducing parsing is a form of bottom up parsing in which a stack holds the grammar symbol and an input buffer holds the rest of the string to be passed. So rest of the thing is where I move towards the root here, right? So we use only symbol which is dollar. We use the dollar to mark the bottom of the stack, and also the right end of the input. The right end of the input, conventionally when discussing with the bottom up parsing, we show the top of the stack on the right rather than left, as we did for top down parsing. So initially the stack is empty. So stack is empty in the sense I have only dollar. So if I have dollar, then I say that it is an empty, right? So and starting with the input, as I said, we start with W dollar. So what is W? W is the input. W is the input. All right. So during left to right scan of the input string, that means I move from left to right. So till from left towards the dollar. The parse shift 0 or more input symbols, that is S, onto the stack. From the input I push it towards the stack. So the stack until it's ready to reduce a string beta of the grammar symbols on top of the stack. So here two things which we do. One is with shifting and the other one is with the reducing. So shifting in the sense I move from production. That means I move the production, that is from the input towards the stack. Input towards the stack. Reducing is where I use my grammar to reduce the particular productions into one particular non-terminal. One particular non-terminal. So number of the productions will be turned into a non-terminal is something called as a reduce. Shifting in the sense I move from one thing to the other thing. So basically moving input symbols towards the stack is called as a shifting, and reducing in the sense the number of productions, the number of input symbols will be reduced to one particular non-terminal. That is called as a reduce. So here this is where it is the stack until it is ready to reduce the string beta of the grammar symbol on top of the stack. If then reduces beta to the head of the appropriate production. The parsers repeats this cycle until it has deleted or detected an error. Until it sees an error, it will be running, or until the stack contains the start symbol and input is empty. So till there this will be running. So two condition, the parser repeats this cycle until it has detected on error. The parser repeats this cycle until it detected an error, or until the stack contains the start symbol and input is empty. So one is the failure condition. If it detects an error, it causes an error, and the other thing is the successful condition. So looking upon the actions in shift reduce parsing is, the definition goes in this way. Shifting in the sense, shift the next input symbol onto top of the stack. That's what I said. So I have shift, stack, I have input, and I have action. So these are the three particular columns which we consider. So under the case of shift, I move from input to stack on top of the stack. So what about reduce? The right end of the string to be reduced must be at the top of the stack. Locate the left end of the string within the stack and decide with what non-terminal to replace the string. That's what I said. So I have to replace the complete whatever the symbols which I have into one non-terminal. So that is called as a reduce. So locate the left end of the string within the stack and decide with what non-terminal to replace the string with. So this is the string with what non-terminal I have to replace. That is called as a reduce. The next two thing is at the end, when to reject it and when to accept it. Accept is when announce successful completion of the parsing. That is, you encounter dollar and dollar. That means I don't have any symbol left out in the stack, or I get out with the starting symbol. I get out with the starting symbol in the stack, and I don't have anything in my input. Getting? So this is about the acceptance of the completion of parsing. Error is where I discovered a syntax error. Yesterday I told you that with respect to the terminals and non-terminals, there will be some tuples, right? So I have all terminals on my x-axis and non-terminals on my y-axis. So according towards non-terminal with the terminal, that is your first value. If I encounter empty block, if I have an empty block there, it's actually a syntax error which will be there. If I encounter this particular box which doesn't have any production, then I can say that we have encountered a syntax error. Next case is working out with it. Once I get with the error, and can an error recover a routine, right? So we also check whether we can recover from the error which has been happened. So these are the four. One is shift, reduce, accept, and error state. So these are the 4 points which you need to be looking into in shift reduce parsing. So find the handles for the given reduce shift function and construct shift reduce parser. I have a production, E tends to E plus T or T tends to T star F or F, and F tends to within bracket E or ID. So here we are reducing it, reducing in the sense I have my input. What is the input? Input is ID plus ID, right? So it is ID1 and ID2. So my input is basically ID1 plus ID2. So what is that we do? E tends to E plus T. This is I'm just working out with the term with the rightmost derivation, e tends to e plus t, and this t will be made as f, then f is made as id, from id plus t is from t to f, and f is to id. This is what the rightmost derivation, which accordingly we start. So same exactly provided into this particular case here. So I have id plus id initially, reduce it, right? So this is from top to down, this is from top to down, and this is with bottom to up, bottom to up. So id plus id is what with the terminal which I have. So here handling with id1, starting from left to right, and this is rightmost derivation. That means rightmost derivation in the sense I start giving the or reducing from right towards the left in rightmost derivation. In this case, I have id1 plus id2, so I have a production f tending to id. So reducing this id to f. Now you can listen that I am using something called as a reduce, right? So reducing this id1 to f. So similarly, f is reduced to t, right? From id2, again I am reducing it to f. Sorry, from f I am reducing it to t. From t I am reducing it to e, right? So e plus id, again I reduce id to f, and from f to t. So similarly, e plus t, what do I have? I have e. I reduce e plus t to e. So I started with the input, and I landed at the starting symbol. So it is, yes, it is right on the track which we are moving. So the first is with id and thing. So what exactly is happening here? So with the shift and reduce options, we go with things related to shift, reduce, accept, and if I have any error, we actually put it. So what does the algorithm say with shift and reduce? So going back here, algorithm says that I have to insert dollar in stack and input in the input, w dollar in the input. As you can see, this is my w and dollar, this is w and dollar, and this is what? This is my dollar, where in the top of the stack. So first is I'm encountering dollar with id1 plus id2 and dollar. So shifting this id towards the stack, right? So here what I do is id1 plus id2 dollar. So what I do is in shift reduce functions, it didn't match, right? So dollar and id, it didn't match. So what do? I move id to the stack. So this is shifting your input from, shifting your input towards the stack. So shift id1, so dollar id1, then I encountered plus id2 dollar. So now what can I do? Can I work out with plus? No, unless I work out with id, I cannot do it. So f is reducing the id to f now. So id becomes what? F. And similarly, working out with f plus id2 dollar. Next thing is reduce t to, from reducing from f to t. So f to t. So t I have from e to e production, e tending to t. So reducing t to e. No, okay. So do I have any other production which I can reduce? E into any other productions? No, I don't have any other productions where I can furthermore reduce e. So what I do, I encountered with plus, push plus towards your stack. So that is your shift operation, right? So next, what did I encounter? I encountered e plus in my stack. So okay, and this term is with this. Okay, so plus id2 or something, things are missing here. So what I did is plus have been pushed. One second. T2 into F. So plus has been pushed. So here I don't have plus here. Alright. So kindly see to that. So E plus is what E has been shifted. And E plus, can I reduce E plus? No. There is no production which is giving me, which can be reduced E plus to anything. Right. So but I have it with E plus T. So as I cannot reduce, I have to push ID2. So that is what shift ID2. So ID2 I have. Can I reduce this equation? Yes, ID can be reduced to F. F can be reduced to T. So yes, E plus T I can reduce to E. Basically this is about the reduction which I am talking about. So starting symbol with the dollar is accept state. So there is no error state which we didn't find out. So the particular string will be accepted. With the same method, looking into this example, ID plus ID star ID. So with the rightmost derivation here, I start with the top, that is your root. So I start with root, moving towards my input. Right, so that's what the method which goes on here. I have taken my input here. So input I am reducing from left to right. That is ID to F, F to T, T to E plus. E plus cannot be reduced, so E plus, this should be made as E plus T. So ultimately E plus T star F. So T star F will be reduced to T, and E plus T will be reduced to E. Similarly, how to run this with the shift reduce. So as the rule says, insert your string, and once you insert your string here, I insert dollar. That means I don't have anything in the stack. So I have ID. So what do I do with the ID? So push ID to the stack. So dollar $ID. Can I reduce this ID to anything? Of course. Reduce ID to F. So F to T and T to E. And with E, can I reduce to anything else? No. So next input is plus. So can I do anything with plus? No. Push it towards your stack. So E plus is what I have. So E plus, I cannot reduce anything with E plus. So what I do, I have a symbol ID2. So what I do, push this ID2 towards your stack. So E plus ID2. Can I further work out with this? Of course. So here E plus ID2. So what do I do with ID2? So ID is made as F. I think few cases are missing here. ID is made as F. F is made as T. And so next what happens is I push star. So T star, and again E plus T star doesn't make any sense. So I have a production with T star F actually, which can reduce to T. So again push ID also. So ID 3 will also be pushed. So that's what the equation here which says. So first F is made as ID, and F is made as T. Then shift the ID, and reduce ID to F. So reducing ID 3 to F, and here the case is T star F can be reduced to T, and E plus T is what I have. So E plus T can be further reduced to E. Similarly the steps. So starting symbol with dollar will give me a success state. I hope I have made sense in explaining few things related to it. So if you have any doubt, you can always ask me, no issues. And anyhow, we'll be explaining you with another one more term or one more example extending to 0, S1 or 0, 1 with the inputs 0, 0 and 1, 1. So let me explain you about this example. So first thing is working out with the rightmost derivation 0, S1. Starting symbol is extending to 0, S1. From 0, S1, can I get 0, 0 or 1, 1? So yes. So I have a production 0, S1 replacing S with 0, S1 again. So 0, S, 1. So and the end I need 3 zeros. So replacing the last S with 0, 1. So I get 0, 0, 1. So anyhow, you know about this working. Next is shift and reduce here. According to the algorithm, my input should be with respect to W dollar. So W is the input string, dollar, and stack will be empty. First thing is shifting 0 to stack. So again, 0 cannot be reduced with any way. So reduce the another 0. So shifting with another 0. Can I do anything with double 0? No. Even another 0 will also be pushed or shift. So triple 0, I can't do anything. So shift 1. So I have 0 1. So I can reduce 0 1 2. Yes. So reduce 0 1 2. Yes. And followed by, can I do anything with 0? Yes. No. I need another 1. So shift 1 to your stack. I have 0s1. So 0s1, what can I do? I can reduce it to yes. So again, pushing your 1 or shifting 1 towards the stack. So I have 0s1. So 0s1 can be further reduced to yes. So starting symbol with the dollar, it is a success state. So what I need you to do now is take down this example of S tending to double S plus S tending to SS star or A. And one more thing, in shift reducing parser, no need to check whether a given grammar is in left recursion or left factoring is required or not. So kindly consider this example here of S tending to SS plus or SS star or A with the input of AAA star A double A. Alright, so you can try it out and send me the results.